The device in your pocket right now is tracking your location using a satellite system calculated by a black woman mathematician who worked for the U.S. Navy. The pacemaker keeping someone's grandfather alive was made possible by a resistor invented by a black engineer from Alabama. The light you are watching this video by, the carbon filament that made it commercially viable, was developed by a black man whose name does not appear in a single major American textbook. Every February the same list appears: the traffic light, the blood bank, the gas mask, the same names, the same photographs, the same 15 minutes of recognition, and then the calendar turns. That framing is the second erasure. Because what happened to these inventors was not incidental, it was structural. There was a system, legal, economic, and cultural, designed to absorb the genius of black Americans, remove their names from the record, and convert their work into someone else's wealth. This is not a list video. This is a forensic examination of 10 cases, documented, sourced, and precise, of what happens when a society decides that certain kinds of genius don't count. You are going to recognize every single thing they built. You are going to know almost none of their names. That is not an accident. That is the story. Number 1. Lewis Howard Latimer. Lewis Latimer was born free in Boston in 1848. His parents had escaped slavery 4 years before his birth. By 14, he was serving in the Union Navy. By 21, he was teaching himself mechanical drawing from library books at night, after his shifts at a Boston patent law office. In 1882, he solved the problem that had made Thomas Edison's light bulb commercially useless. Edison's original bulb worked, but the filament, the thread of material that carries the current and produces the light, burned out in hours, sometimes minutes. It was a novelty, not an infrastructure. Latimer developed and patented a method for encasing the carbon filament in a way that made it durable, stable, and manufacturable at scale. That process is the reason cities could be electrified. That process is the reason you turned on a light this morning. Edison hired him, used his work, built an empire. When the Edison pioneers, the inner circle of the electrical age, were finally documented for history, Latimer was listed, the only black member. And in every major textbook account of the invention of the light bulb, there is one name. It is not Latimer's. Number 2, Dr. Gladys West. Dr. Gladys West grew up in Sutherland, Virginia, the daughter of tobacco farmers. She graduated as valedictorian of her high school, won a scholarship to Virginia State University, and in 1956 joined the Naval Surface Warfare Center at Dahlgren, Virginia, one of only a handful of black employees. For the next 20-plus years, she fed data into a computer and refined a mathematical model of the Earth's shape, accounting for the way gravity varies across the planet's surface, accounting for the way those variations affect the orbit of satellites, accounting, with precision that would not be recognized for decades, for every variable that makes it possible to determine an exact location anywhere on Earth. That model became the computational foundation of the global positioning system. When GPS was celebrated as one of the engineering triumphs of the 20th century, Gladys West's name was not in the official history. In 2018, she was inducted into the Air Force Space and Missile Pioneers Hall of Fame. She was 87 years old. The phone in your pocket has known where she was for decades. The world did not. Number 3, Dr. Charles Drew. In 1940, the British military was hemorrhaging soldiers faster than blood transfusions could save them. The problem was not the willingness to donate. The problem was storage. Whole blood degrades within days. Transporting it to active combat zones was logistically impossible at scale. Dr. Charles Drew, a surgeon and researcher at Columbia University, had already solved this problem. His research demonstrated that plasma, blood with the red cells removed, could be stored far longer than whole blood, could be transported across continents and oceans, and could be delivered to soldiers in the field without refrigeration failures destroying the supply. He organized the first large-scale blood banking program in American history. He directed the Blood for Britain project that supplied the Allied forces during the Second World War. The infrastructure he built became the model for the American Red Cross National Blood Bank program. The American Red Cross then implemented a policy of segregating black and white blood donations. Charles Drew, the man who built the system, publicly opposed the policy as medically absurd. There is no biological difference in donated blood between races. The policy was not science, it was politics. He resigned. The policy continued for years after his death. Drew died in 1950 in a car accident at 45 years old. The system he built has saved millions of lives and continues to today every time someone survives emergency surgery. Number 4. Granville T. Woods. Granville T. Woods held over 60 patents. 60. And he defended every single one of them in court against some of the most powerful industrial interests in American history. His multiplex telegraph allowed a moving train to communicate with a fixed station, both directions, simultaneously while the train was in motion. Before this invention, trains ran blind. A dispatcher knew when a train left a station. He did not know where it was between stations. The result was collisions, regularly, lethally. Wood's system changed that. It is the technical ancestor of every modern rail communications infrastructure. His induction telegraphy system became the foundation for the third rail electrical supply that still powers subway systems in New York City, London, and cities across the world. Thomas Edison sued him, twice, claiming the multiplex telegraph was Edison's invention. Woods won both lawsuits. Edison then offered to buy him, not to hire him, but to absorb his patents, his future output, and his name from the commercial record. Woods eventually sold several patents to what became General Electric and Westinghouse, not because he wanted to, because the cost of defending his ownership in court had exceeded the cost of surrendering it. He died in 1910, in a charity hospital in New York City, in poverty. The systems he built still move millions of people every day. Number 5. Dr. Patricia Bath. Before Dr. Patricia Bath, removing a cataract required a surgeon to manually extract the clouded lens from a patient's eye using a blade. The procedure was invasive, imprecise, and carried significant risk of permanent damage. Blindness was a common complication. Recovery was measured in weeks. Bath invented the Laserfoco probe, a device using laser energy to dissolve and remove cataracts with precision no blade could match, and a gentler, faster, safer restoration of sight. Her patent, filed in 1981 and granted in 1988, was the first medical patent granted to an African-American woman in American history. She faced institutional resistance at every stage. When she first proposed establishing a program in ophthalmology at UCLA in the early 1970s, she was told the program did not exist because blacks and women were not considered suitable for ophthalmology. She established the program anyway. It became the Jules Stein Eye Institute. Her invention has restored sight to patients in countries around the world, including patients who had been blind for decades. She died in 2019, after a lifetime of refusing to accept the limitations placed on her by institutions that were wrong about her. Number 6. Otis Boykin. The resistor is the most common component in modern electronics. Every circuit board, every device that runs on electricity, contains resistors, components that regulate the flow of current with precision. Without them, electronics as we know them don't exist. Otis Boykin invented a wire precision resistor that was cheaper to manufacture, more reliable across temperature extremes, and more consistent than anything previously available. It became foundational to the electronics industry. IBM used it. Military guidance systems used it. Consumer electronics used it. His most consequential application was in the control unit for artificial cardiac pacemakers, the device that regulates an irregular heartbeat, keeping it consistent, preventing arrhythmia, keeping a person alive, depends on precise electrical regulation. Boykin's resistor provided that precision at the scale that made pacemakers producible at medical grade. Otis Boykin died in 1982 of heart failure, a cardiac event. His invention at that moment was helping keep the hearts of thousands of other people beating. Let that land. Number 7. Dr. Mee Jemison. On September 12, 1992, Dr. Mee Jemison became the first black woman to travel to space. That is the fact that history recorded. It is not the most important fact about her contribution. Jemison was a physician, a chemical engineer, and a Peace Corps medical officer before NASA selected her. Aboard the Space Shuttle Endeavour, she conducted research on bone cell research, biofeedback, and the effects of weightlessness on the human body. Research on microgravity that informs every long-duration spaceflight mission planned since. The question of how human physiology responds to extended periods without gravity is not an academic one. It is the central medical problem of every Mars mission, every deep space initiative, every plan to put a human being anywhere in the universe beyond the moon. Her research is in the foundation of that conversation. She was also the first real astronaut to appear in a Star Trek episode, a moment she requested as a condition of her schedule. She has cited Nichelle Nichols, Lieutenant Uhura, as the representation that made her believe someone who looked like her belonged on a starship. The cycle of that representation matters. It always has. Number 8. Garrett Morgan. In 1916, there was a tunnel collapse beneath Lake Erie in Cleveland. Crews were trapped below in a space filling with toxic gas and smoke. Garrett Morgan, a black businessman with a history of self-funded invention, put on one of his prototype gas masks, led a rescue team into the tunnel, and pulled survivors out. The national press reported the rescue. When they discovered the man who led it was black, several papers changed their stories. Some omitted his name. Some credited white colleagues who were not present. He patented the gas mask. He patented the 3-position traffic signal, the device that added the yellow caution light between stop and go, the architecture that governs every intersection in the modern world. He sold the traffic signal patent to General Electric for $40,000 in the 1920s. Adjusted for inflation, that one-time payment today is approximately $700,000. General Electric built a global traffic management industry on that foundation. That industry generates billions annually. Morgan received one payment. His family received nothing of what came after. Number 9. Mark Dean. The personal computer, as you know it, was not built by one man, but the architecture of the original IBM PC, the bus system that allows all the components inside a computer to communicate with each other, was co-designed by Mark Dean, a black engineer from Jefferson City, Tennessee. Dean holds 3 of the original 9 patents that define the IBM PC. He later led the team that developed the first gigahertz computer chip, a milestone that represented an order-of-magnitude leap in processing speed. He was the first black engineer inducted into the National Inventors Hall of Fame. In 2011, he published a commentary in which he observed that the PC had peaked as a significant device, that mobile and cloud computing had superseded it. He was noting the obsolescence of something he helped build. That is an extraordinary kind of perspective, to create a foundation and then watch civilization grow beyond it. The laptop you are watching this on, or the phone, or the tablet, runs on architectures that descend directly from the design principles Mark Dean helped establish in 1981. The device is different. The lineage is not. Number 10. Dr. Shirley Ann Jackson. In 1973, Shirley Ann Jackson became the first black woman to earn a doctorate from MIT in theoretical physics. She joined Bell Laboratories in 1976, where she spent the next 15 years conducting research that would define the telecommunications infrastructure of the modern world. Her work in semiconductor physics provided the theoretical foundation for developments including caller ID, call waiting, the touchtone phone, fiber optic cables, and the technology underlying solar cells and fax machines. She did not invent all of these devices. She built the scientific foundation that made their invention possible, the theoretical architecture that a generation of engineers built on. This is perhaps the least visible form of contribution and the most foundational. The person who discovers the underlying principle, who proves why something is possible before anyone knows how to do it, is the invisible architect of everything that follows. She went on to serve as chair of the U.S. Nuclear Regulatory Commission. She became the first black woman to lead a major research university as president of Rensselaer Polytechnic Institute. Every time you check your caller ID, you are looking at the downstream application of theoretical physics work done by a black woman in a laboratory in New Jersey. In the same decade, that institution was actively debating whether women and black researchers belonged there at all. These are not 10 stories. They are one story told 10 times. A black innovator works within a system that does not grant them the capital to build on their own invention. They file the patent, or they don't. They sell it under duress, or they fight the lawsuit until the legal costs consume them. They are credited in the internal record and excluded from the public one. They die sometimes in poverty, sometimes in comfort, almost always in relative obscurity, while the systems they built generate wealth that compounds for generations in the hands of institutions that absorbed their work. The question this raises is not sentimental, it is economic. What does it cost a society to systematically root credit, and therefore capital, away from a portion of its most productive innovators? What industries did not exist because the inventor could not access the funding to commercialize them? What medical breakthroughs arrived late, or never, because the researcher hit a ceiling no white colleague faced? What technologies were built on a foundation that was never compensated, never acknowledged, never compounded? We can calculate some of that. We can approximate the gap between what was paid and what was earned. What we cannot calculate is the innovation that never happened, the next invention, the one that would have followed if the conditions for invention had been equitable. That is the true cost, not the $40,000 paid for a traffic signal patent, not the credit line that was never extended. The cost is the compounding absence of what could have been built, discovered, and shared if the system had let it. 10 names, 10 inventions embedded in your daily life. The question I want you to sit with, and I want to see your answer in the comments, is this. If these 10 people had been given the full economic value of what they created, the compound returns, the equity in the industries they founded, the royalties that never came, what would the wealth gap in America look like today? Drop your answer below, and I want to hear which one of these inventors you had never encountered before today. Next, we go back to Black Wall Street, but this time with a calculator. The real economics of what was destroyed in 1921, converted to $2026 and modeled across a full century of compound growth. The number will rearrange how you think about the wealth gap. That's the next video. Subscribe.